Because if you don't know what the basic graphs are and how to get them, then it doesn't do you any good to learn anything else. So, starting off with the basic graphs. Let me get this out of the way so it doesn't bleed through all over that stuff. So, basic graphs. We'll start off with those. So, we start off with sine and cosine because sine and cosine are pretty much the exact same graphs. Whenever we get to the other four are way different than sine and cosine. Just a second. Okay. Now, to get the graph from this, we're going to use the unit circle. What we're going to do is we're going to use the 90-degree marks. So we're going to use 0. The next mark that we're going to use is going to be pi over 2. And then we're going to use pi. I feel like I'm getting my spacing mixed up. 1, 2, 3, 4. I'm doing my spacing is kind of random. There's no reason to leave 4 marks. I'm just doing it to spread it out a little bit.
Is each space on one of these sheets?
Use however many spaces you want.
Okay.
It's
So I can use one for each mark.
You can use 1 for each mark. You can use 5 between each mark. It doesn't matter. And I'm going to go ahead and I'm going to go backwards too. Okay, before we get started with the actual graphing, we talked about this in the last chapter. What is the largest value that sine can give you? 1. So the largest y value my sine can be is 1. What's my smallest value? -1. You can tell right now my x and y value or graphs are not to scale. I left 4 marks in between my pi over 2's, and I left 4 marks in between my y values. We do that so that it looks decent. That's the only reason. We just want it to look pretty. If you do it on a graphing calculator, you'll notice that there is a special zoom feature called zoom trig, so that it looks better. Because if you keep it spaced by 1s, it doesn't look as good. That's why you have a special zoom trig, just to make it look better. That's the only reason for it. Okay, so now I'm going to go back and I'm going to use my unit circle to figure this out. So I can put this on here in case you need a visual or you guys have your own unit circles. All right, so at 0, what does sine equal? Remember, sine equals the y values. 0. Okay, at pi over 2, what does sine equal? Okay, at pi, what does it equal? Nope, 0. At 3 pi over 2, what does it equal? And at 2 pi? Okay, if I were to go backwards, so if I would take this and go backwards, negative pi over 2 would be down here. So what would it equal at negative pi over 2? Negative 1. Okay, so if I go backwards negative pi, what does it equal? 0. And negative 3 pi over 2? So negative 3 pi over 2 would be 1. So that's how we get our points. They just come from the unit circle. Okay, now this is a curve. Kind of think of it as again, your unit circle kind of laid out. Whatever you're drawing, so you're kind of curving it as you draw. And it keeps going on forever because your circle keeps going on forever. We talked about that. We can go around our circle as many times as we want to, so the sine curve goes on forever. Sometimes it's called a sine wave because it looks like a wave. And actually, a lot of times sine and cosine are used to, not a lot of times, they are always used to model the equations for sound waves and that kind of stuff, because they match the actual sound and sound waves, water waves, everything like that. All right, so cosine, we can copy down all our units for cosine, because we're going to use the exact same units for it. And again, cosine, the value can never go above 1 or negative 1. And hopefully it makes sense to you that it's going to look the same, because as we go around the circle, cosine gets the exact same values as sine does. Yep. Look at your circle. As you go around your circle, does your circle ever give you any values bigger than that? And even whenever we do trig of other things, so like even when we use the fractions like 3 and, or use OR pairs like 3 and 4, whenever we create those fractions, the fractions are never give you a number bigger than 1. Okay, now whenever we do this though, the values change a little bit. So whenever you look at 0 on here, what's the value at 0 now? 1. And now the value at pi over 2 is 0. And the value at pi is going to be -1. 3 pi over 2 is 0. And 2 pi is back to 1. And going backwards, you're going to have 0, -1, and 0. So again, looks like the same exact curve. It's just shifted over. So instead of the peak being at pi over 2, now the peak is at 0. All right, so there's your memorization to start with. You have to know, it's like knowing what the base function is for x squared. You had to know what the graph is for x squared before you can graph x squared functions. Well, you have to know what your base graphs are for sine and cosine before you can do any graphing with them. So if anything really needs to be memorized, here's the start of your memorization. You have to know what these functions are. You have to know where to start them. You have to know that sine starts at 0, cosine starts at 1, that kind of stuff. Okay. So that's great, but of course, you know, you're never going to be given graph y equals sine of x. So we need to go a little bit farther. I have some definitions for you. And then that's going to change our equations. And then we're going to graph with those new equations. Okay. First one, take our highest point or our lowest point. Shouldn't matter which one. And the distance between the center line and the highest point or lowest point, we use A to label that. That is called amplitude. Now, the way I have this one drawn, the center is the x-axis. It does not have to be the x-axis. So the center could be, it could be at 3 if the graph gets shifted up, which eventually we'll do shifting with our graphs. So the graph will get shifted around. So, you know, if the center's at 3, great, the center's at 3. It's the distance between the top of the graph and 3. Okay, so that's amplitude. Next thing is called period. Which we talked about a little bit, but I told you it would make more sense when we got to graphing. I said time. It shouldn't be time. It should be distance. And changing that one word doesn't matter a whole lot as long as you know what you're talking about. Time deals with frequency, which I'll show you what frequency is. Now, the normal period of sine and cosine is 2 pi. So if you look at this, like if I take this highest point on cosine, I don't go back to that highest point until out here at 2 pi. So the graph doesn't repeat for a distance of 2 pi. Same thing with sine. If I take this point here at 0, it doesn't get back to that point until 2 pi. Well, you might say, well, it hits 0 again here. It does hit 0, but at this point of 0, it's going down. You have to get back to the point of 0 where it's going up. So it doesn't get back to the point of 0 where it's going up until out here at 2 pi. So sine and cosine have a period of 2 pi normally, unless we change that, which we're going to do. And then graph it. Okay, so that's our 2 new definitions, newish. The other thing that I just said that I would talk about just a little bit, it doesn't come into play so much in what we're doing. It's more of a physics thing, but it's frequency. Frequency is 1 over the period. We'll do a little bit more with that later on in this chapter. We do have some questions that talk about frequency. You take your period and you divide by it, and that actually has to do with the time. Frequency is how many waves pass a point per second, or per a given amount of time. So it'd be, if I take this point, how many waves pass this point in a second? So that's frequency. So again, we'll talk more about that later. I'm not too concerned, but that's why I changed the period from time to distance, because frequency is the one that deals with time, not period. Okay, so this is how it shows up in our graphing, in our equations. Now, you might say, well, I see A there, but I don't see P. Why don't I see P? Oh, that's because P doesn't show up in your equation. You have to do work to find P. Yay us, right? So, A is normal. A equals amplitude. However, period is equal to 2 pi divided by B. that's how you find your period. You take the number in front of the x and you divide by it. Yeah, well, maybe not much. That's all farther it'll scoot up. All right, so I want to spend some time going through some examples, and then we'll be done for today. Because really, this is what can get you started on some of the homework. What? B doesn't technically stand for anything. If you want B to stand for something, B stands for your period, or 2 pi divided by your period. That makes a lot of sense, doesn't it? B is just a number that's given in your equation that you can use to find your period.
It's just a coefficient.
Yeah. So here, we'll get to it in a second. Example 3, 2 would be B. It doesn't do anything for us until we actually use it to find your period. But let's start off with example 1. Don't ruin the surprise. My God.
You should be happy on retreat.
Okay. Just to make it a little bit quicker, normally on tests and stuff, I'm going to ask you to graph 2 periods. So that means you graph whatever a period is. So in this case, the period would be 2 pi. So you'd graph out to 4 pi, or you'd graph 2 pi and then 2 pi in the opposite direction on a test or something. For notes and stuff, to make it a little bit quicker, and you can even do it on homework, I'm just going to do 1 period. Or whatever will fit. So, just to make this a little bit quicker, I'm just going to graph 1 period. Let's see, this is a little bit shorter, so I'm just going to go here. Pi over 2, pi, 3 pi over 2, 2 pi. Here's my normal 1, my normal -1. Now, since the amplitude is 3, A is 3. All that does is, instead of going up to 1, I'm going to go up to 3. Now, sine starts at 0, so that doesn't affect 0. But pi over 2 should be at 1. So instead, what I'm going to do is I'm going to go up here to 3. Then back down to 0. Then down to -3. Then back up to 0. So there's 1 period of sine with the amplitude of 3. Now, if you wanted, you could keep going. Again, it's not difficult to keep going with this. I would just make the next mark. Get which part? All of it. So I put my 3 points I need, or my 4 points I need to put, right? Okay. I know that sine starts at 0. I go 0, 1. So here's my, again, you need to learn your basic graph. That's one thing I have the advantage of knowing that you don't yet. You need to work on. So looking at your basic graph, there's your basic graph. So the amplitude being 3, all that does is take these 1 values and takes them times 3. So I take this point and move it up here to 3. I take this -1 and move it down to -3. Yep.
we don't, with the negative sign,
What negative sign?
like you don't do.
Oh, going backwards?
Yeah.
On a test or something, yes. You need to put